Hello my dear students, welcome to IMS Academy. I hope you are doing great. My dear students, IMS Academy is a YouTube channel where you can find a systematic approach for the GATE preparation. You name, especially in civil engineering, we have done the GATE score booster, we have done the actual smart revision with a formula sheet, and now we are into the top 10 questions which will challenge and which will be covering in the GATE pattern. So my dear students, we at IMS Academy, if you are providing the session-wise session which are helpful for the GATE preparation, So my dear students, if you are really preparing for the GATE exam, then what are you waiting for? You have to visit our YouTube channel and get the access to all the sessions. And remember my dear students, we at IMS Academy provides offline GATE coaching, online GATE coaching, and also recorded sessions. We at IMS Academy offer the offline GATE coaching at Jayanagar near Bangalore, and also we are providing the offline GATE coaching at Vijayawada near Bench Circle. Students, why IMS Academy and what are the silent features of IMS Academy? We at IMS Academy offers 800 plus hours of offline GATE coaching which includes subject-wise material, and also we have exercise book which covers level 1, level 2, level 3 questions. Here in this level 1, level 2, level 3 questions, we will be covering the NIT, MSQs and MCQs. And my dear students, if you are testing yourself, practice makes man perfect. So here we have the wonderful test series which includes chapter test, subject test, advanced level test, and also multiple subject tests. And remember my dear students, in GATE actual environment, you will be writing the GATE exam for 3 hours, and in this same environment, we are also providing you the All India mock test series which will test yourself. So my dear students, if you want to have all the features at one place, IMS Academy has better advantage. In addition to this, why people and why students at IMS Academy are successful? We at IMS Academy, all the mentors are providing one-to-one sessions to the students. Suppose if he is a diploma student, he might face difficulty in the mathematics. So how his weakness can be converted into strength? These kind of small things which will help you in the entire journey of your preparation will be taken care. In addition to this, if you want to solve all the doubts and if you have some questions, some specific topics doubts, you can post the doubt in the doubt solving portal and that doubt can be resolved in 24 hours of time. So I don't want to waste your time. Quickly I will move on to the top 10 challenging questions topic. So here my dear students, see here we have a beautiful question. My dear students, when I talk about the these question in RCC we have a weightage of around 4 marks in the GATE exam. Whatever the questions which I am covering, please concentrate on these topics rather than on the questions also, and you have to be give more precise and you have to give more importance to the concept. So my dear students, here is a question. A singly reinforced concrete beam with a width of 300 mm and an effective depth of 400 mm is to be designed by M25 concrete and FE 500 grade. For a beam to be under reinforced, what is the maximum number of 16 mm dia bars? So let us understand my dear students, what do you mean by under reinforced and what do you mean by over reinforced and what do you mean by balanced section? My dear students, in practically it is impossible to have a balanced section. Okay, practically it is impossible to have a balanced section. Then immediately your friend will ask me, sir, why we are assuming a balanced section? My dear students, to find the depth of neutral axis, we assume the section to be balanced. And what do you mean by under reinforced? When an amount of steel provided is less than the amount of steel required. What, sir? How much amount of steel you are providing? It is less than the amount of steel required. Then we call it as under reinforced. So my dear students, if you are playing a match India between Zimbabwe are rated as underdogs. So under reinforced means whatever you required, it will be provided less. So here the failure is obviously in steel because you are providing the less amount of steel. So as steel is a ductile material, it shows a clear sign of failure. That is the reason practically all the sections are designed as under reinforced. When you consider over reinforced, amount of steel provided is more than the amount of steel required. The failure is in concrete, whereas concrete is a brittle material and the failure will be sudden, which is not at all acceptable in the design of a structure. So as a structural engineer, all the practical sections are designed as under reinforced. So let us understand what are the conditions. What are the conditions for under reinforced section? My dear students, the conditions for under reinforced section are very clearly known that the condition for under reinforced section is XU less than XU max. What do you mean by XU? Depth of neutral axis is less than limiting depth of neutral axis. Similarly, area of steel provided is less than the area of steel or limiting area of steel. Based on these two conditions, we assume the section is said to be under reinforced. I hope you are clear about the conditions of under reinforced. Now see students, now you know for a balanced section, what sir? For a balanced section, if I consider a balanced section, what do you mean by balanced section? That means the amount of steel required is how much you want to balance the section, that much amount of steel is provided. So the conditions for balanced section are XC is equal to XU max. Please understand this question. A condition, AST is equal to AST limiting. Now my dear students, if I consider the section to be balanced, we can find the limiting area of steel. Okay, very good, very good. So here when I considered compression force is equal to tension force. So my dear students, when I say compression force is equal to tension force, what do you mean by compression force here? 0.36 FCK B into XU max. Sir, it is as simple as that. Here 0.36 FCK B into XU max is the compression force, and we have tension force is equal to 0.87 Fi into area of the steel. So you know my dear students here, area of steel. So what is the grade of concrete we will see. The grade of concrete is M25 and the width of the section is 300 and effective depth is 400. So here what is the grade of concrete students? The grade of concrete is 25, width of the section is 300. Now my dear students, based on the grade of the steel, XU max values changes. Suppose see students, if it is a mild steel or Fu 250, XU max value, please understand this students, very important, this will be equal to 0.53D. If it is Fe 415, HYSD bar, what do you mean by HYSD? High yield strength deformed bars. For Fe 415, we call it as 0.48D. And my dear students, if I talk about Fe 500, this will be taken as 0.460. Now in this problem, it is evident and it is clear that the grade of the steel is 500. So I will be providing you here 0.46 into D, where effective depth is equal to 400 mm. Now my dear students, let us solve here is equal to 0.87 Fi. Fi yield strength of the steel is 500. And I told you my dear students, in balanced section, AST, area of steel, and limiting area of steel, both are same. So here, when I talk about limiting area of steel, we will take AST or limiting area of steel. Okay, see here again students. When you see here, the effective grade is, the strength of the grade of concrete is M25 and the width of the section is 300, effective depth is 400. So these are the values given in the data. Now my dear students, here we have only one unknown. So after solving this, if I solve here, what will be the AST limiting, sir? What will be the limiting area of steel? limiting area of steel will be equal to 1142.06 mm square. Limiting area on calculation you will get 1142.06 mm square. But what he is asking, for a beam to be under reinforced, what is the maximum number of bars? So here, for a beam to be under reinforced, AST should be less than AST limiting. So here what will be the value, sir? Number of bars is equal to number of 16 mm bars he is asking. So here it will be 1600 A square is equal to 1142.06. Okay. Now if you consider here number of bars, you will get as 5.68. Now what will be the number of bars you will get? 5.68. But most of the students might write the number of bars answer as 6. If you write 6, this is absolutely wrong. Why? Because when you provide more area of steel than limiting area of steel, what happens is the section will become over reinforced. But for a beam to be under reinforced, 116 mm bar is also correct, 216 is correct, 316 is also correct. But what he has asked in the problem, what is the maximum number of 16 mm dia bars? That is the question he has asked in the problem. So in that case, my dear students, the maximum number of bars that can be provided for a section to be under reinforced is 5 number. Again and again I am insisting you and consistently telling you, for any section to be under reinforced, XU should be less than XU max, AST should be less than limiting area of steel. So my dear students, to solve this problem, first I have find out the limiting area of steel. So how can I find the limiting area of steel? I assume the section to be balanced. Based on the balanced concept, I have calculated the limiting area of steel as 1142.06 mm square. But see students, for a beam to be under reinforced, the amount of steel which you are providing should be less than that. So I have got number of bars as 5.68. But if you write the answer as 6, if you are providing more amount of steel than the required, then you tell that it is a over reinforced section, where your assumption itself will be wrong. But the beauty of the question is, sir, I will tell you one of the beauty of this question. The answer can be 1, 2, 3, 4, 5. But that is to eradicate that, he has used the word maximum number of bars. So when I write maximum number of bars means the answer will be 5. I hope this solution is clear and you are enjoying this session. Now let us go into the next question. Now my dear students, whenever you are following GATE exam pattern or whenever you are writing the GATE exam, it is my sincere advice to all the GATE aspirants of GATE 24, whenever you have given a question, please go through the question completely with the given data for at least 30 seconds to 45 seconds. Because this understanding of the question, given the data, please write whatever the given data in a paper so that you will strike which formula you have to use. So this is very important for your success in GATE exam. So please read the question carefully. A launched varying depth reinforced concrete beam is simply supported at both ends. The beam is subjected to a uniformly distributed load intensity of 10 kilonewton per meter. The design shear force of the section. Beautiful question. Let us see, sir. Sir, see students, it is a varying section. First of all, it is a varying section. Okay. Now see students, when I consider the design shear force, which we will show it as VDS. Actually, design shear force can be written as VU plus or minus M by D tan beta. Okay. This is the formula to calculate the design shear force for a varying section. Now, the challenging aspect here is, when do you come with positive sign and when do you come with negative sign? Sir, see, here in simply supported beam, if you consider the bending moment diagram, it will be something like this. So it will be maximum at center and minimum at ends. So my dear students, as the depth is increasing, the moment is decreasing. In this case, you will use positive sign. If the depth is increasing, the moment is increasing, then we will use negative sign. So let us have a clarity on this. As depth increases, moment decreases. As depth increases, moment decreases. When the depth is increasing and moment decreasing, in this case, what you will be using, my dear students? You will be using negative sign. Okay? Now, as depth decreases, moment, depth is decreasing. So here you can say moment also decreasing. Or you can write here one more thing, sir. As depth increases, to avoid confusion, moment decreases. What, sir? See, students, as depth increases, moment decreases. As depth increases, moment decreases. So here, see, students, here as depth increases, moment decreases. Depth is increasing, moment is also decreasing. In this case, you will use positive sign. When do you use negative sign, sir? As depth is increasing, moment is also increasing. You should write here, moment increasing. Sorry, sir. Moment increases. Are you getting my point? One case is depth is increasing, moment decreasing. In this case, you will use positive sign. If depth is increasing, moment is also increasing, then you will use negative sign. So, my dear students, in this question, whether we have to use positive sign or negative sign, so the answer will be positive sign we have to use. Because as the depth is increasing in this section, what is happening to the moment? Moment is decreasing. So, we will use positive sign. So, my dear students, let us conclude that design shear force is equal to Vu plus m by d tan beta. Why we are having positive sign here? As depth is increasing, moment is decreasing. Okay? That is then we are using the positive sign. Now, if you see, we consider a simply supported beam, okay, which is carrying a load of 10 kilonewton per meter. And if you see here, students, the span is having a length of 20 meter. Now, when you talk about the span carrying how much load, sir? 10 kilonewton meter and 20 meter. What will be the reaction here? It will be equal to WL by 2. And here also it will be equal to WL by 2. So, this will be equal to 10 into 20 upon 2. This will be equal to 100 kilonewton. So, the reaction at supports will be equal to how much, sir? 100 kilonewton. But he is asking what is the reaction at a section X, which is at a distance of 5 meter. So, my dear students, if I calculate Vu, that is shear force at the section XX, which is at 5 meter, you can write it as the reaction 100, whatever the reaction you have here, that is 100 minus this 5 into 10, W into X bar you can write. So, the shear force at that section will be equal to 50 kilonewton. What, sir? The shear force at that section will be equal to how much, my dear students? It will be equal to 50 kilonewton. Now, if you talk about the moment, what will be the moment at that section, sir? The moment at that section is at 5 meter. We have reaction is how much? 100. So, 100 into 5, this is nothing but force into perpendicular distance, minus what is the UDL load? 10 kilonewton meter. And it is occurring at a distance 5 and it will occur at the center. So, if you calculate this, moment will be equal to 375 kilonewton meter. What will be this value, sir? 375 kilonewton meter. Now, see, students, my dear students, here if you see, the depth at the center is how much, sir? 400 mm. The depth at the support is 600 mm. The overall span is 10 meter here up to here. He is asking at the center. So, you can directly write depth is equal to 600 mm plus 400 mm by 2. What, sir? Depth can be written as clearly 600 plus 400 by 2, which will be equal to 500 mm. Which will be equal to how much, students? This will be equal to 500 mm. In meter, if you write, this value will be taken as 0.5 meter. Okay. Now see, my dear students, if I talk here, if I talk about the design shear force, if I talk about the design shear force at that section, we have the formula Vu plus m by d tan beta. Now see, students, what will be tan beta value? See, if you see the section here, if I see the section here, now see, students, the span from here to here is how much, sir? This is 10 meter. And this depth, if you see here, this is 400 mm. And this will be equal to how much, sir? 600 mm. So if you see here, what will be this value? This value will be equal to 200 mm. This value will be equal to 200 mm. So what is this value beta? So here tan beta can be written as 200 divided by 10,000, because 10 meter is 10,000 mm. So if I calculate here, you will get tan beta is equal to 0.02. Now my dear students, when I talk about the design shear force, here we have shear force is equal to how much, sir? 50. Okay, 50 plus moment is how much? 375 kilonewton meter upon depth is how much, sir? Depth is nothing but 0.5 meter into 0.02. So you will get it is, if you solve this, you will get 50 kilonewton plus 15 kilonewton. So you will get the final answer as 65 kilonewton. So the final answer here is 65 kilonewton. So my dear students, whenever you are whenever you are solving the gate question, you have to read the question carefully. I will tell you, if it is for a uniform section, so whatever you learn in SOM, strength of materials, that you can directly applicable here. But when I talk about varying section, in the concept of shear, we will be explaining this. So how do you explain this is, for a varying section, the design shear force is given by the formula Vu plus or minus m by d tan beta, where Vu is the shear force at that section, m is the moment at that section, d is the depth at that section. When do you use positive sign is, as the depth is increasing, moment decreases. What, sir? As depth increasing, I have written here, as depth is increasing, moment decreases, positive sign. As depth is increasing, moment also increases, then you will use negative sign. Sir, I have given you example for simply supported beam, we will be using positive sign. But if you see a cantilever beam, students, if you see a cantilever beam here, see here the depth is increasing and at the same time moment is also increasing. So in this case, you will be using negative sign. So I hope you are clear with this problem and you have enjoyed this problem. Now my dear students, this is a very, very important problem, sir. Assume a straight line instead of parabola. For a straight line, partial safety factor is 1, and a rectangular under reinforced concrete section of 300 mm and 500 mm. Effective depth is reinforced with 3 bars of grade Fe4 and 5, each of 16 mm dia. Concrete mix is M20. The depth of the neutral axis from the compression fiber and the depth of neutral axis differs from the depth of neutral axis from the compression fiber is by, as per IS 456. Now here I will tell you some important concepts, my dear students. Actually, my dear students, there is a method called limit state method. What is the method called, sir? Limit state method. What do you mean by limit state method? Previously, there is a method called working stress method. But nowadays, people are using the limit state method because it is more beneficial and in the safety point of view as well as in the economical point of view. So what is a limit state method is? It is a method of designing a structure based on statistical concept of safety and probability of failure. Or in simple words, it is the ultimate stage at which the structure is unfit for use. So this is all about the LSM method. In LSM method, my dear students, the stress strain curve is assumed as rectangular parabolic. How the stress strain curve is assumed? It is assumed as rectangular parabolic. Based on that calculations, we have got compression fiber is equal to 0.36 FCK B into XU, and tension force is equal to 0.87 Fy AST, and lever arm is given by the formula. Lever arm you can write here. Lever arm is given by the formula D minus 0.42 XU. So this is all the important formulas from IS 456 code. Now my dear students, in this problem let me tell you the stress distribution. If I have taken this as a singly reinforced section, okay, if I take this as singly reinforced section, if you see the stress distribution is triangular and rectangular. It is not rectangular parabolic. As per the code, it is rectangular parabolic. But in this question, they have given it as triangular parabolic. And if this will be the strain diagram, okay, which is varying linearly. Now see students, what is the stress here given in the problem? 0.65, 0.67 FCK. Why it is 0.67 FCK, you can ask me. Sir, actually, the partial safety factor for concrete, if you take, it is equal to 1.5. When I do this, 0.67 FCK divided by 1.5, you will get a value of 0.446 FCK. But here what is happened in this problem is, they have given the partial safety factor as 1. So here what I have to do is 0. FCK divided by 1 will be given as 0.67 FCK. So my dear students, I take the stress as 0.67 FCK, and anyhow you know the strain. The strain value is 0.02, and if I take it as depth of neutral axis as XU, I'll take this distance as X dash. Okay. Now from similar triangles you can write. Here you have the value, strain value is 0.0035. How do I know 0.0035? From the code. So here I can write that XU divided by 0.0035 is equal to X prime upon 0.002. Now my dear students, X prime can be written as 4 by 7 XU. What is X prime, sir? 4 by 7 XU. My dear students, here this value is 4 by 7 XU. So what will be the remaining value? The remaining depth will be XU minus 4 by 7, which will be equal to 3 by 7 XU. Now we will write the compression force here. I am writing the diagram again for your easy understanding. This is 0.67 FCK. This is 3 by 7 XU. And this value is 4 by 7 XU. Now my dear students, what will be this? How to solve this is, compression force is, sir, how do you calculate force? Force is nothing but the area of the pressure diagram, or it is the area of the stress block. So compression force can be written as 0.67 FCK into area of the, sir, see, this is a rectangular block, right? I can write it as B into 3 by 7 XU. And for triangle, how can you write? This is the triangular part, which will be equal to half into base into height. So you can write as half into B into 4 by 7 XU. So this will be the compression force. Okay, sir. Now what will be the tension force? Tension force, there will not be any change. It will be equal to 0.87 Fy AST. Now see, you know compression force, you know the tension force. What will be the compression force, sir? What is the grade of concrete given in there? The grade of concrete is given as how much, sir? 3 bars of Fe4, 300, 500 mm, 3 bars and M20 grade. Let us solve. Sir, see, compression force can be written as here, if I write here, 0.67 FCK. FCK is how much, sir? 20 grade. 0.67 FCK. Okay, B into XU. Width is 300. XU you don't know. Plus B into XU, sir, C. Plus half into B is 300. Sir, XU means what, sir? Here it is 3 by 7 XU. So into 3 by 7. Here it is B 4 by 7. Half into B into 4 by 7 XU. B into 3 by 7 XU is equal to, what is the grade of concrete? The grade of concrete is how much, sir? I think it is 415. So you should be writing 415 and 3 bars of 16 mm dia. So 415 grade of steel. And how much, sir? 3 bars of 16 mm dia. 3 into pi by 4 into 16 square. So what will be the depth of neutral axis? Can anyone tell me? What will be the depth of neutral axis? Sir, depth of neutral axis XU will be around 75.8 mm. If you solve this, you can approximately take as 76 mm. So the first case, whatever he has asked in 1, you will get the answer as 76 mm. I hope you are clear. Are you following, my dear students? Very good. Now, what he is asking, I will tell you. In the second case, he want to tell us as per the IS 456. Sir, as per IS 456 means we know already what do you mean by compression force. I told you compression force is equal to what, sir? Compression force is equal to tension force. If I apply here, what is compression force? 0.36 FCK B into XU is equal to 0.87 Fy into AST. So this is the formula for what, sir? Compression force and tension force. So here what is compression force? What is the grade of concrete? 20. What is the width of the section? 300. We don't know what is XU is equal to 0.87. What is the grade of steel we have? 415. And what is the area of steel, sir? Area of steel is 3 bars of 16 mm dia. So 16 square. So if you solve this, what will be the XU value? Can anyone tell me? Sir, see, XU value will be roughly around 100.8 mm. Okay, or you can approximately assume as 101 mm. But he is not asking what is XU. He is asking what is the difference in XU calculated in the previous case and in the present case. So the difference in depth of neutral axis can be written as 101 minus 76. This will be equal to 25 mm. What is the difference in depth of neutral axis? The difference in depth of neutral axis is taken as how much, sir? 25 mm. So see here, the options here is, one is the 76 mm, correct? And other one we have is the C option, that is 25 mm. So my dear students, let us explain what do you mean by limit state method. In limit state method, sir, according to the IS 456, the stress strain distribution, the stress distribution is rectangular parabolic and the strain distribution is linear. When I talk about the rectangular parabolic, students, we have the standard formulas, like we have derived compression forces 0.36 FCK B into XU is equal to tension force, which is 0.87 Fy AST. But in this problem, instead of here, it should be rectangular and parabolic. But here he has given triangular and parabolic, triangular and a rectangular. So here what I would like to tell you is, there is a clause in IS 456. IS 456, the clause says that the stress strain distribution can be any shape if the test results are satisfied. Based on that, they have framed this question. Actually, in one of the class, I am telling you again and I am stressing you, IS 456 says that the stress strain diagram need not be rectangular parabolic. It can be any shape. It can be any shape. But the clause is the test results should be satisfied. So here they have given as triangular and rectangle. But my dear students, here if you see the grade of concrete, it is 0.67 FCK and the yield strength is partial factor of safety is how much, sir? 1. So using this, I have derived the compression force. What do you mean by compression force, sir? Area of the stress diagram. But whereas traditional IS 456, the partial safety factor for concrete is 1.5. But in this problem, they have given the partial safety factor as 1. So that is the reason I have taken stress as 0.767 FCK. I hope this solution is clear for you. My dear students, if you are looking for a systematic approach how to prepare for the GATE exam, and after the GATE exam, are you looking for the post-GATE guidance, like which college you want to apply, and based on the marks which you have to do, means for which PSU you want to apply, we at IMS GATE Academy will give you all the updates. You can join in the Telegram group for all the updates, what's happening through the GATE exam. So let us move on to the next question. So here we'll go on to the next question. So my dear students, there is an excellent question here, sir. A rectangular beam width 230 mm, effective depth 450 mm, is reinforced with 4 bars of 12 mm. The grade is M20, TUC and all. So here, my dear students, you have read the question. What is asking? What is the spacing? See, he has given the spacing. What is the dia of the bar is asking. So let us go through this problem. So actually, my dear students, before understanding shear has been very important, because to understand the depth of foundation, we want to study about shear. Actually, the depth of the foundation depends upon one-way shear or two-way shear, and based on the shear criteria, we take the depth of foundation. Another important thing is there can be different cracks in RCC. One is flexural cracks or shear cracks. So if you are having high shear force, there are a possibility of shear cracks. So to avoid the shear cracks, to estimate the depth of the foundation, students should have a better understanding of shear. And remember, my dear students, if you want to be success as a structural engineer, even though the marks are less in the GATE exam, but for a better perspective in the design, definitely RCC subject is very, very important. And if you want to join in the industry as a structural engineer, RCC code book is also very important. So let us go into the shear, sir. Suppose, see students, first I will talk about the nominal shear stress. My dear students, first what I will talk, sir? I will talk about the nominal shear stress. Now what do you mean by nominal shear stress is? Nominal shear stress is nothing but tau V is equal to Vu upon Bd. What is nominal shear stress, sir? Tau V is equal to, nominal shear stress is equal to, tau V is equal to Vu upon Bd. And my dear students, if tau V is less than 0.5 tau C, no shear reinforcement is required. My dear students, these things are very, very important, sir. When tau V is less than 0.5 tau C, no shear reinforcement is required. If tau V is less than tau C, you should understand that there should be minimum shear reinforcement. If tau V is less than tau C, what you have to do? Minimum shear reinforcement. So, my dear students, you should be aware of the formula. What do you mean by minimum shear reinforcement? Minimum shear reinforcement is given by the formula ASV into BSV is equal to 0.4 upon 0.87 Fy. This is a very, very important concept. I am expecting this year. I am not sure, sir, but this question is very important, this shear concept. If tau V is greater than tau C, shear reinforcement is mandatory. What, sir? Shear reinforcement is mandatory. So, what is the formula here? I will tell you. Sir, this is the formula for nominal shear stress. This is the formula for minimum shear reinforcement. For shear reinforcement mandatory, we have design shear force is equal to 0.87 Fy ASV into D upon SV. Okay, sir? Now, see students, let us go into the problem. First, we will calculate tau V. What do you mean by tau V here? Tau V is nothing but shear reinforced by B into D. So, my dear students, what is the shear force given in the problem? Sir, what is the shear force given in the problem? Sir, it is B is 230 mm, effective depth is 450 mm. And what is the shear force given in the problem? Can anyone? So, shear force is given as 45 kilonewton. Okay, sir. Now, we will calculate the nominal shear stress. How do you calculate the nominal shear stress? Can anyone tell me, sir? So, nominal shear stress is nothing but shear force is 45 kilonewton. So, 45 into 10 power 3. Now, width of the section, what is B, sir? B is nothing but 230 mm. And what is the effective depth? Here, effective depth is given as how much, sir? 450 mm. So it is 450 mm. So tau v is equal to how much? Tau v can be written as 0.434 Newton per mm square. What, sir? Tau v can be written as 0.434 Newton per mm square. Now, how do you calculate tau c here? How do you calculate the tau c? Tau c depends upon two things, sir. It depends upon the grade of concrete and also it depends upon the percentage of steel. It depends upon what, sir? Percentage of steel. So here percentage of steel is nothing but we have to calculate as AST by BD into 100. So they have given you what is the area of the steel given in the problem, sir? Can anyone tell me? So they have given C. What is the area of the steel they have given? It is reinforced with they have given C. Here please see, students. It is reinforced with the 4 bars of 12 mm dia. So reinforcement is how much, sir? 4 bars of 12 mm. So here if I calculate PT, so 4 into pi by 4 into 12 square. And what is the width of the section, sir? The width of the section is 230 mm and depth of the section is 450 mm. So what will be this value of percentage of steel? What will be this value of percentage of steel, sir? So if you calculate here, the percentage of steel will be equal to 0.437%. How much it will be equal to? 0.437. Now here see, students, they have given the tau c value for 0.25 percentile, for a PT value of 0.25 percentile, and they have given for a PT percentile of 0.48. So how much they have, sorry, 0.5. Sir, see, tau c for PT is equal to 0.25. They have given as 0.36. For 0.5, they have given as 0.48. Now, what is your intention? You have to find the permissible shear stress, tau c, for a percentage of, how much, sir? We have got PT value, 0.437. Okay, 0.437. So, for a percentage of 0.43 percentile, what will be this value? So, how to calculate this? By interpolation, sir. So, for 0.25 it is 0.36. So, 0.36 plus, what is the difference between these two? So, this will be equal to 0.48 minus 0.36 upon, what is the difference between these two? 0.5 minus 0.25 into this value is multiplied by 0.437 minus 0.25. Sir, this is nothing but interpolation, sir. Find out the difference between these two and find out the difference. This is the fraction I got into what is the, for which value you are finding. I have done that. So after solving this, you will get tau c is equal to how much, sir? Tau c is equal to 0.45 Newton per mm square. How much you will get, sir? Tau c is equal to 0.45 Newton per mm square. Now see, students, what is the tau v we got? Tau v is 0.434. Now see, students, from the question, it is evident that tau v is less than tau c. When tau v is less than tau c, we will be providing the minimum shear reinforcement. What, sir? When tau v is less than tau c, what you will do? You will be providing the minimum shear reinforcement. So minimum shear reinforcement, what we have to do, sir? The formula for minimum shear reinforcement is ASV upon B into SV is equal to 0.4 upon 0.87 Fy. So my dear students, sir, what is ASV means? ASV is nothing but the area of the stirrups. So here if you see students, what is the area of the stirrups is? They are using the diameter of 5 feet, two-legged. So two-legged to be used with a spacing of 375 mm. Spacing is how much, sir? 375 mm. So here you can say 2 into, we have to find out the dia bar. So 2 into pi by 4 into d square upon width of the section is 230 mm. Spacing they have given as 375 mm is equal to 0.4 upon 0.87. Grade of steel is how much, sir? They have given. Sir, if they have given mild steel, you have to take mild steel 250. But here they have not mentioned FE grade of FE 405. So let us once again check that, sir, whether they have used the diameter of FE 400. Sorry, FE 500 they have given. So here you should write grade of steel is given as Fe 500. On solving this, see students, what is the dia of bar you will get is, around 7.88 mm. A dia bar cannot be a fractions like this. So it should be the dia of bar answer will be 8 mm. I hope this solution is clear for you. Now my dear students, let me explain you the insight of the shear. What do you mean by shear is? Shear is responsible for cracks and the depth of foundation depends upon shear, sir. So there can be two chances, okay? Either cracks or the depth of the foundation. Now see students, we call tau V as nominal shear stress and tau C as maximum permissible shear stress. When tau V is less than 0.5 tau C, no shear reinforcement. When tau V is less than tau C, we provide minimum shear reinforcement using this formula. This formula is very important. Why I have used here 2? Because it is a two-legged stirrup. If they used the word two-legged, you should be very careful. SV is known as the vertical spacing. Fy is the grade of the steel. Sir, when I am using Fy, grade of steel, you have to be very specific and you have to clearly note that whatever the main steel grade might be different and stirrup grade might be different. So please be cautious while solving this problem. I hope this solution will be clear and this solution will help you to solve the problem. Okay, now see students, this is a beautiful question, sir. According to the concept of limit state design, the probability of the failure of the structure is, what is the probability of failure of structure? Now see students, see. Sir, why LSM method is highly appreciated? Because LSM method is designed for, why LSM method is highly appreciated, sir? Because it is designed for higher loads and it is designed for lesser strength. What, sir? Why LSM method is highly appreciated? It is always designed for higher loads and lesser strength. This will ensure you double safety. What, sir? As a design engineer, structural engineer, we always take safety as the highest priority. As it is ensuring double safety, we are going with LSM method. But in this problem, what he has asked is, according to the limit state of method, what is the probability of failure of structure? So, how the structure can fail, we have to study, sir. How the structure can fail, that can have an impact on this problem. Sir, see, structure can fail in two ways. Either load can be, suppose, see, first case is, if the load is more than the, whatever you are taking the load is more than the design load, then obviously failure will happen. Okay, sir, if the load is more than the design load, failure will happen. Next case is, if the strength is less than the characteristic strength or if the strength is less than the characteristic strength, then also failure will happen. Then also, because strength is less than the actual strength, it should have a strength of some 100. If it is having 80, then also failure will occur. Or the cases of both, or having a cases of both, load greater than design load and strength having both. So my dear students, how do we solve this problem? So first, to take the probability into action, if the load is greater than design load, the probability of failure of the structure is only 5%. Sir, see, three cases can affect here. What is load failure? Load failure alone. These are two independent events. If you study probability, dependent and independent events, you can have an idea. And strength fail alone. And both fail. Both strength and load will fail. Sir, see, whenever they are independent events, we can say, we can write, if suppose, if they have given you load of P of A union B, if they are independent events, you can write it as P of A upon P of B. Same concept I will apply here. First, load failure is 0.05 and strength is passing. So 95 percentile, it will pass. Sir, characteristic strength means it is the strength at which 95% of the test results are expected to fail. Sorry, expected to pass. So this is one combination. Other thing is load will pass 0.95 and strength will fail. So it will be 0.005. And the other case is both failure. Both strength and load will fail. So this case will be 0.05. So this is load failure and also strength failure. If you solve this, you will get a value of 0.0975. If you solve this, you will get 0.0975. So the probability of failure of structure can be written as 9.75 percentile. I hope this solution is clear. So what are the key points in this problem? I will tell you, students. Either load can be more than design load, or strength can be less than characteristic strength, or both load and strength can be lesser than the allowable values. Both the cases can fail. So these are the cases where a structural can fail. So I have taken these three into account and I have calculated both, because strength and load are independent factors, and I have applied the probability rule and I have got the value as 0.0975. I hope this solution is clear for you. Okay. Students, one thing I would like to tell you, we at IMS Gate Academy are offering the like January 26th offer, Republic Day offer exclusively for offline gate coaching at Jayanagar and also offline gate coaching at Vijayawada. Sir, one more thing I would like to tell you, in Andhra Pradesh, we are the only center who are offering the offline gate coaching near Bench Circle. If you want to experience the feel of the offline gate coaching, definitely near Bench Circle, opposite to the Enadu office, you can visit our center, have a demo and have an interaction with the student awareness team. Definitely all the features, actually students, you should be aware what are the actual opportunities through GATE exam. Especially if you are from a core branch like civil engineering, you can get into the public sector companies, you can get into the masters in IITs, or if you are writing state level exams, or if you are writing SSC, JE, or senior section engineer, railway department. So many opportunities are there. And remember, my dear students, GATE is the only exam where you can study and prepare while you are studying your BTech. So my dear students, if you want to be success in your life, if you are 1 year of life, if you be focused, you can enjoy the 30 years of your life. So please be focused on GATE, especially civil, mechanical and electrical students. They have a better opportunity in PSUs and other branches also. It doesn't mean that other branches are also, but these three branches have an extra advantage to getting into GATE, sir. Now let us see this question. The question is, when a specimen of M25 concrete is level of stress is induced to a stress level of 12.5 MPa, a strain of 510 power 6, if this is allowed to 1010 power 6 in accordance with the provisions considering the effective long-term modulus of elasticity. Now see students, I will tell you. See students, if they consider you short-term modulus of elasticity. Sir, previously short-term modulus of elasticity, according to the, means we have a revised code and we have the old code also. With the old code, you might have seen short-term modulus of elasticity as 5700 root FCK. But with the revised code, the short-term modulus of elasticity is given by the formula. The short-term modulus of elasticity is given by the formula 5000 root FCK. What is the short-term modulus of elasticity, sir? The short-term modulus of elasticity is given by the formula 5000 root FCK. So here if I talk about this, you have short-term modulus of elasticity is equal to 5000 into root FCK. What is the root FCK, sir? You can write the grade of the concrete is 25. You can write here 25,000 Newton per mm square. So the short-term modulus of elasticity is how much, sir? 25,000 Newton per mm square. Now, my dear students, what do you mean by long-term modulus of elasticity? The long-term modulus of elasticity is given by the formula short-term modulus of elasticity upon 1 plus theta, where theta indicates creep coefficient. What do you mean by theta, sir? It is nothing but the creep coefficient. Here you can write theta is equal to creep coefficient. Theta is nothing but the creep coefficient, where you can write theta is equal to ultimate creep upon, theta can be written as ultimate creep upon elastic creep. So my dear students, if you see here, what is theta? Ultimate creep is how much, sir? You can write it as 500 into, you can have ultimate means 1000 minus 500 into 10 power 6 or 10 power minus 3, sir? We have one is what, sir? 10 power 6. So into 10 power 6 ultimate creep, and elastic creep can be written as 500 into 10 power minus 6. So on solving this, you will get creep coefficient as 1. So if I substitute creep coefficient 1 in this, you got short-term modulus of velocity is how much, sir? 25,000 Newton per mm square upon 1 plus theta is 1. So you'll get a value of 12,500 Newton per mm square. So the long-term modulus of velocity is how much, sir? 12,500 Newton per mm square. So see students here, what I would like to tell you here is, when I talk about short-term modulus of velocity, it is given by the formula 5000 root FCK. Long-term modulus of velocity is given as short-term modulus of velocity upon 1 plus theta, where theta is the creep coefficient and theta is defined as ultimate creep upon the elastic creep. I hope this solution is clear for you. So let us move on to the next question, sir. Now see students, this is another important question. Sir, see, in a structure, what is a structure? Is a group of structural elements connected together. Suppose if a load is applied on the slab, it will be transferred to the beam and then to the column and then to the footing. So here what I would like to tell you here is, a reinforced concrete beam of width, effective depth is 80 mm, is simply supported at opposite ends of 230 mm thick masonry walls. Center to center is 3.3 meter. As per IS 456, the effective span of the slab. Now see students, he is asking effective span of the slabs. Sir, effective span we have. Sir, first we will discuss about two cases. One is simply supported beam, because in this problem they have given simply supported beam. Sir, effective span for simply supported beam, case A, it can be center to center distance between the supports. Students, are you following? If you have any queries, please feel free to write in the chat box. So SSB is nothing but the center to center distance between supports. Center to center distance between supports, or you can write clear span plus D. Sir, if it is for cantilever, it is clear span plus D by 2. So out of these two, which will be your effective span? Remember, my dear students, the smaller will be taken as effective span. Are you following, students? Smaller value will be taken as effective span. I hope you are clear. So what is the effective span, sir? It is the distance between the center to center distance between the supports, or clear span plus D. So here, my dear students, let me tell you one important thing here. What do you have is, here there is a simply supported slab or anything, and here there is a wall, okay, of thickness, how much, sir? Of thickness 230 mm. Okay, this thickness is 230 mm, or you can write it as 0.23 meter. Now see students, if this is center to center distance is how much, sir? 3.3. Now how can you write clear span? Sir, clear span will be this distance. So what you can do, clear span can be written as, here, clear span can be written as center to center distance minus thickness of wall. You can write from the diagram, you can write it as center to center distance minus thickness of the wall. Here, what is the center to center distance? Here it is 3.3 minus 0.23 meter. You will get center to clear span as how much, sir? 3.07 meter. Now see students, what is the other formula I told you for effective span for simply supported beam? It is defined as effective span is equal to clear span plus effective depth D. So here clear span is how much, sir? 3.07 meter plus effective depth is how much? 80 mm. That you can write it as 0.08. So the final answer you can write it as 3.15 meter. Final answer, how much you can write, students? You can write the final answer as 3.15. So I hope the final answer 3.15 meter will be the minimum. When, sir, 3.3 and 3.15, which is the minimum? So 3.15 is the minimum. I hope this solution is clear. So my dear students, whenever you are preparing for the GATE exam, you have to, whenever you are preparing for the subject RCC, you should be aware of the code. So what are the key points in this question is, according to the IS code 456, there is a clause that the effective span of simply supported beam is, it is the center to center distance between the supports or clear span plus D. Out of these two, whichever is the minimum. If you talk about cantilever beam, it is clear span plus D by 2. I hope you have enjoyed this question. So my dear students, there was a question in a post-tension concrete beam. He is asking the elastic deformation of concrete. Now see students, please read the question carefully. A post-tensioned concrete member of span 15 meter and a cross section of 450 into 450. Each cross-sectional area is 200 mm square. The tendons are having a stress of 1500 MPa. All the tendons are straight at 120, located at 125 mm from bottom, and what the modular ratio is 6. Now let me tell you, there are various losses in pre-stressed concrete. Now see students, loss due to elastic shortening. When all the wires are tensioned at a time in post-tension, there is no loss due to elastic shortening. If they are tensioned one by one, there will be a definite loss. So my dear students, when I talk about the loss of pre-stress, what sir? The loss of pre-stress. The loss of pre-stress due to elastic shortening. What sir? The loss of pre-stress due to elastic shortening. The loss of pre-stress due to elastic shortening is given by the formula. Can anyone tell me, sir? It is given by the formula M into FC. What is the formula, sir? The loss of pre-stress due to elastic shortening is given by the formula M into FC. Now, my dear students, here you should be clear. What do you mean by M, sir? M is nothing but modular ratio, which is the Young's modulus of steel upon Young's modulus of concrete. What, sir? It is the Young's modulus of steel upon Young's modulus of concrete. Now, what is FC? Sir, here, my dear students, FC is nothing but the stress at the level of steel. FC is nothing but what, my dear students? It is nothing but the stress at the level of steel. So when I talk about the stress at the level of steel, FC, you have this point, see student. FC can be written as load upon area plus PE square upon I. So this is nothing but FC. What do you call FC? FC is nothing. Sir, this is important. Why? Because see students, actually if you take a pre-stressed concrete beam, the steel will be somewhere here. If I consider this as neutral axis. Usually what we'll do, when I talk section modulus, usually we take at the extreme fiber. So when they tell you stress at the level of steel means the distance from neutral axis to the steel plate, we usually call it as eccentricity. I hope you are clear. So here, my dear students, first we have to calculate the load. So load, how do you calculate? Load is nothing but stress into area. So load is equal to stress, pre-stress into area. Area of each tendon is how much, sir? 200 mm square. They have given 1500 into area 200. So my dear students, you can write as 13 to 10 power 3 newtons, or you can write as 300 into 10 power 3. So you can write it as 300 kilonewton. Now see students, how I will calculate FC. FC is nothing but what, sir? Load. Load is how much? 300 into 10 power 3 upon area. Area of the section is 450 into 450. Now my dear students, how do you calculate eccentricity? Sir, see, here we have a strip, rectangular beam. If I consider this as neutral axis, the depth is how much, sir? 450 mm. Suppose, if you consider the half of it will be 450. Now see students, they have told that tendons are placed at a distance of 125 mm from bottom. So this will be, so total is 450, sir. So half will be equal to how much, students? Half will be equal to 225 mm. So actual eccentricity will be equal to 450 by 2 minus bottom distance is 125. So eccentricity will be equal to 100 mm. Are you clear, my dear student? So eccentricity will be equal to 100 mm. So load into 100, load is 300 into 10 power 3 into eccentricity square is how much, sir? 100 square upon I. What is I, students? It is nothing but BD cube by 12. Because for a rectangular section, BD cube by 12. So 450 into 450 cube by 12. Now, what is the stress at the level of steel? Anyone, my dear students? What is the stress at the level of steel? If you solve this, you will get a value of 2.36 Newton per mm square. What, sir? 2.36 Newton per mm square. Now, my dear students, the loss of pre-stress due to elastic shortening, is given by the formula m into Fc. Okay, sir, it is given by the formula what? M into Fc. So here, what is m, sir? You can write m is nothing but 6 modular ratio, Fc is nothing but 2.36. So this will be equal to 14.16 Newton per mm square. So my dear students, you should be aware of the key point that how do you calculate the loss of pre-stress due to elastic shortening. The loss of pre-stress due to elastic shortening is calculated by the formula m into Fc, where m indicates the modular ratio and Fc indicates the stress at the level of steel. Okay, here what do you mean by modular ratio? It is the ratio of Young's modulus of stress upon concrete. What is Fc? It is nothing but the stress at the level of steel. I hope you are clear with this. Now we have a beautiful question here, students. Now what is this question? A rectangular post-tension concrete beam of span 10 meter, width 150 mm and depth 300 mm is pre-stressed by a cable of initial stress of 1200 MPa. The cable is parabolic with an eccentricity of 50 mm towards the tension zone. Coefficient of friction is 0.3. Wobbling constant is 0.05. The percentage of pre-stress, sir, see, is asking what is the percentage loss of pre-stress due to friction. Sir, this is very important number. This also, the percentage of loss of pre-stress due to friction. You can say, sir, percentage means delta P upon P naught into 100, sir. Change in or loss of pre-stress by initial pre-stress into 100 will be the percentage loss. But here, if you ask me what is the loss of pre-stress means, you can write it as P naught into mu alpha plus K into X bar. This is the formula for what, sir? Delta P. Okay, loss of pre-stress. You can write loss of pre-stress instead of percentage loss. I will write, sir. So here what do you mean by P naught here is, P naught is nothing but initial stress, sir. What is P naught here? P naught is nothing but initial stress. My dear students, let me tell you one important thing in friction. If the cable is tensioned from one end, it will be taken as P naught. If the cable is tensioned from both ends, this is very important, sir. When you are solving the problem, they can give you cable tension from one end and cable tension from both ends. If it is tensioned from one end, we will take it as P naught. And here mu is nothing but coefficient of friction. What is mu, sir? Coefficient of friction. Okay. And my dear students, what is K? K is called wobbling constant. K is called wobbling constant. Sir, what do you mean by wobbling constant here means? Suppose, see students, if I consider a wire, it will be flat like this. But due to tensioning operation or anything, the wire might be like this. This is called wobbling effect. Okay, sir. And what is the X bar? X bar is nothing but the length of span. What is X bar, sir? Length of span. X bar is nothing but the length of the span. And what is alpha here is? Alpha is nothing but the cumulative angle. Alpha is nothing but the cumulative angle in radians. Alpha is nothing but the cumulative angle in radians. And K is wobbling constant. Alpha is nothing but the cumulative. Mu is the coefficient of friction. Now let us solve this problem. Loss of pre-stress delta P can be written as P naught into mu alpha plus K into X bar. Now everything is given in the problem except alpha. But see students, here the span is how much, sir? the span is in this way, the tendon is parabolic. So see students, we have an angle theta here, theta 1 and theta 2. Now see students, alpha can be written as theta 1 plus theta 2. Because it is symmetric, you can directly write it as 2 theta. Sir, in some cases, it might not be theta 1, theta 2 might not be same. So how do you calculate theta is? Sir, you know dy by dx is nothing but slope. Okay, we know, I'll tell you, y is equal to what, sir? 4h by L square into x into L minus x. So if you solve this dy by dx, you can write it as 4h by L square minus L minus 2x. Sir, what is x means? X is the distance from supports. So you can write dy by dx as what, sir? Tan theta. Tan theta can be written as 4h by L. For small values of theta, tan theta can be written as theta. So my dear students, here theta is written as 4h by L. So what will be alpha? Theta plus theta, that is 2 theta, which is equal to 2 into 4h by L. Okay, which is equal to 8h by L. Sir, you might have asked me, sir, how do you got that? Because in a parabolic equation, the generalized equation of parabola is, sir, you might have studied in a structural analysis also, 2 in the arc and all. Y is equal to 4h by x, L square into x into L minus x is the standardized formula for parabola. So using this, I've calculated this. Now what? Now my dear students, let me tell you how do I calculate. Delta P is equal to P naught into mu alpha plus K into x bar. So here I have to calculate alpha. Alpha is nothing but what, my dear students? 8h by L. Sir, here h is nothing but the eccentricity, which is equal to 8 into 50 mm. Okay, upon length is 10,000. So if you solve this, alpha will be taken as 0.04. Now my dear students, you know everything. Delta P can be written as P naught into mu is 0.3 into 0.04 alpha plus K is how much, sir? 0.015 into x bar is length of the span is 10. On solving this, if you solve this, you will get 0.027 P naught. Okay. Now what we have to do? Delta P by P naught into 100. Okay, if you solve this, you will get, see, 0.027 P naught upon P naught into 100. You will get a value of 2.7 percentile. So the percentage of loss of pre-stress due to friction is given by the value how much, sir? 2.7 percentile. Again and again I am repeating, my dear students, whenever there is a loss due to friction, it is clearly evident that the loss due to friction is observed only in post-tension. There is no loss due to friction in pre-tensioning members, first point. And the next point is the loss of pre-stress due to friction. Delta P is given as P naught into mu alpha plus K into x bar. Here what do you mean by P naught? It is the initial stress. If it is tensioned from one end, it will be P naught. If it is tensioned from both ends, it will be P naught by 2. Mu is the coefficient of friction, alpha is the cumulative angle in radians, K is the wobbling constant, and x bar is the length of this span. Based on this formula, just plug in the values, and alpha is nothing but the cumulative angle in radians. So some cases, sir, the alpha value will also vary. Suppose if the eccentricity, there might be a parabola in this case. So in this case, the height of the parabola will be this one, sir. Okay, if you see in my gate score booster, I have done this kind of problem also. So my dear students, I think losses of pre-stress in this year exam, there are high chances, sir. So I hope you have enjoyed this question. Okay, my dear students, let us go into the last question of the today. A pre-stressed rectangular beam 250 into 600 mm is pre-stressed by 414 mm bars of height located at 200 mm from the suffix of the beam. The effective stress in the steel stress is 700 MPa. What is the maximum bending moment due to applied? So my dear students, at the soffit means bottom. You should know that at soffit means bottom. So first of all, I would like to tell you what is the stress at bottom is given by the formula. First, due to direct load. The stress due to direct load is given by the formula load upon area P by A plus what is the stress due to the other thing? That is not the stress due to the moment. The stress due to the moment is, moment can be written as P into E upon Z. What is Z, sir? Section modulus. How PE by Z came, sir? You know, M by E is equal to F by Y. Okay, M can be written as, sorry, F can be, I'll write here. M by E is equal to F by Y. Here bending stress can be written as M by Z. So this is the stress due to the eccentric loading minus moment due to dead load plus moment due to live load upon section modulus. Okay. Now what happens is, there to avoid tension means this value will be equal to 0. Okay. Now I can write using this equation, P by A plus PE by Z can be written as moment due to dead load plus moment due to live load upon Z. So first of all, we should calculate what is the load in this problem. So here load is what, sir? Sir, see, the steel wires are located at 200 mm from the soffit. So if you calculate the eccentricity will be equal to 100 mm. How I will tell you. And the effective stress is 700 MPa. Effective stress is how much, sir? 700 MPa. Sir, see, eccentricity is nothing but, I told you, the section if you consider here, this is totally 600 MPa, 600 mm. So what will be the stress to the this will be 300 mm. And if you see, the wires are located at 200 mm from the suffix. So here the wires are located here at 200 mm. So what will be the eccentricity? 600 by 2 minus 200. You will get a value of 100 mm. So you got eccentricity. Okay, sir. Now how do you calculate the load? Load is calculated as stress into area of the steel. So stress is how much they have given? 700 MPa into area of the steel is 4 bars of 14 mm square. Okay. So my dear students, if you solve this, you will get 700, 4 cancel, it is will be 196, or you can say 200. 1 second, students. 700 into 4 upon pi by 4 into 14 square is 196, right? So 0.7, 2.1. So you will get a value of 431.2 kilonewton. How much value you will get, sir? 431.2 kilonewton. Agree, students? Now you calculated the load, you know the eccentricity, and what is the section here? Section is 250 into 600. So let us apply that formula. Load is equal to 431.2 into 10 power 3 kilonewton. Section is 250 into 600 plus 431.2 into 10 power 3 into eccentricity is 100 upon 250 into 600 square upon 6 is equal to MD plus ML, moment due to dead load plus moment due to live load, into 250 into 600 square by 6. So 250 into 600 square by 6 means 100. If you multiply that, if you solve this, sir, you will get moment due to dead load is 86.2 kilonewton per meter. So my dear students, whenever you are preparing the questions on RCC, sir, please be cautious. Please go through the IS 456 code, and if you have time, just go through the formula sheets. Definitely LSM method, shear and losses due to pre-stress, you will have a better advantage, sir. So my dear students, let me tell you one important thing. What are the silent features of all the best for your GATE exam, amma. As I think the GATE exam is on February 3rd. So my dear students, all the best for GATE 24 exam, and students who are appearing for GATE 2025 and who want to start preparing for GATE 25, definitely you should start preparing from now, because GATE is an exam where it requires systematic preparation. So what are the silent features of IMS GATE Academy is, we offer online coaching, offline GATE coaching, and also self-recorded sessions. If you are interested for offline GATE coaching, I proudly say that we are the only institute in Andhra Pradesh who are providing the offline center at Vijayawada near Bench Circle opposite to Enadu office. We also provide the offline GATE coaching at Jayanagar near the metro station, Jainagar metro station only, and we provide 800 plus hours of gate coaching. We provide you the subject wise material, exercise books which contain level 1, level 2, level 3 questions, and it includes MSQ, MCQ and NAT questions. And my dear students, wherever you want to test yourself, you have to practice the test series. So we provide subject wise test, chapter wise test, multiple subject test, advanced level test. In addition to this, we provide the all India mock test which appears similar to the GATE exam. And my dear students, if you are a real aspirant of GATE, it is not only securing the, means you have to join the Telegram group which is given in the description. If you are a really GATE aspirant, first try to understand what are the opportunities through GATE exam. You can get into MTech in IIT or NIT or PSU public sector companies. In addition to these things, students, if you want to improve or if you want to work in a corporate environment as a structural engineer or a transportation engineer, your actual engineering concept should be strong. And in this GATE exam, when you are preparing for the GATE exam, even state level exams, SSC, JE, almost you will cover 80% of the syllabus, and the 100% syllabus for technical will be covered through the GATE exam. So this is the only exam where you can prepare while studying itself. And all the best for GATE 24 students who are appearing for the GATE exam. Please be patient, be positive and stay healthy. Thank you and all the best.